Have we already received alien messages without knowing it? Source: SETI Institute research. For more than half a century, humanity has been listening. Powerful radio telescopes sweep across the night sky, searching for a signal that could answer one of the oldest questions ever asked. Are we alone in the universe? So far, the silence has been overwhelming. No confirmed transmissions. No unmistakable evidence of an advanced civilization. Just the endless background noise of the cosmos. But what if that silence is an illusion? What if alien civilizations have been broadcasting all along, and their messages have reached our solar system, but we simply failed to recognize them? According to a new study from the SETI Institute, that possibility may be far more realistic than anyone expected. The problem may not be that extraterrestrial civilizations are silent. The problem may be that their own stars are scrambling their messages before they ever escape into space. To understand this idea, imagine standing on one side of a dense forest while someone on the other side shines a perfectly focused laser pointer toward you. If nothing blocks the beam, you see a bright, sharp point of light. But now, imagine the beam passing through thick fog, swirling smoke, and constantly shifting air currents. Instead of arriving as a clean point, the light spreads into a faint, blurry glow that becomes almost impossible to distinguish from its surroundings. The SETI researchers believe something remarkably similar may be happening across the galaxy. For decades, the search for extraterrestrial intelligence has focused on one particular type of signal: extremely narrow radio transmissions. Nature rarely produces radio waves concentrated into an incredibly small range of frequencies, but advanced technology easily can. That makes narrowband radio signals one of the strongest possible signatures of intelligent life. If another civilization wanted to announce its existence, many scientists assumed it would transmit a sharp, highly focused radio beacon. SETI telescopes have therefore spent decades searching for these narrow spikes hidden within the cosmic radio background. But the new research suggests there is a critical flaw in that strategy. The signal leaving an alien transmitter may not be the same signal that eventually arrives at Earth. Every star exists inside a dynamic environment filled with charged particles known as plasma.det. These particles stream outward as stellar winds, carrying magnetic fields across entire planetary systems. Stars also experience violent eruptions. Massive explosions called coronal mass ejections hurl enormous clouds of plasma into surrounding space. Our own sun produces these events regularly, occasionally disrupting satellites, radio communications, and even electrical grids on Earth. Now imagine an alien civilization orbiting a star far more active than our own. Its radio transmissions must first travel through this turbulent ocean of plasma before escaping into interstellar space. According to the new study, that journey could dramatically alter the signal. Instead of remaining a perfectly narrow radio spike, interactions with turbulent plasma gradually spread the signal across a wider range of frequencies. The total energy remains the same. But instead of being concentrated into one bright peak, it becomes smeared into a much broader and fainter pattern. It's like pouring a bucket of paint onto a wall. The same amount of paint is present, but once spread across a much larger surface, it becomes far less noticeable. To radio telescopes optimized for razor-thin signals, that broadened transmission may simply disappear into background noise. Not because it isn't there, but because scientists have been looking for the wrong shape. Rather than relying purely on computer models, the researchers turned to an unexpected laboratory much closer to home: our own solar system. Spacecraft continuously send radio signals back to Earth while traveling through the sun's plasma environment. Those transmissions experience many of the same physical effects expected around distant stars. By carefully analyzing spacecraft communications, scientists measured exactly how turbulent plasma distorts narrowband radio signals. They then applied those measurements to different types of stars throughout the galaxy. The results revealed that some stellar environments could broaden radio signals far more dramatically than previously appreciated. One group of stars stood out immediately. Dwarf stars. Although smaller and cooler than the Sun, these red stars are extraordinarily active. They produce powerful magnetic fields, intense stellar flares, and highly turbulent plasma environments. Ironically, they are also the most common stars in the Milky Way. Roughly 3 out of every 4 stars in our galaxy belong to this category. Many recently discovered Earth-sized exoplanets orbit M-dwarfs, placing them among the most promising locations in the search for potentially habitable worlds. But according to the new research, these same stars may also be the most efficient at scrambling technological radio signals before they escape into space. If intelligent civilizations exist around M-dwarfs, their transmissions could be arriving at Earth looking completely different from what SETI searches have traditionally expected. This possibility offers a fascinating new perspective on one of astronomy's greatest mysteries, the Fermi paradox. If intelligent life is common throughout the universe, why haven't we found evidence of it? Many explanations have been proposed. Perhaps intelligent civilizations are extremely rare. Perhaps they destroy themselves before becoming interstellar. Perhaps they deliberately remain silent. Now another possibility enters the conversation. Perhaps they are transmitting, and perhaps we have already received those signals. But instead of appearing as sharp technological beacons, they arrive blurred and scattered by the violent plasma storms surrounding their own stars. The message reaches us, but becomes almost impossible to recognize. The discovery also highlights an important lesson about scientific exploration. Sometimes the obstacle isn't a lack of data, it's the assumptions we bring when interpreting that data. Next. For decades, SETI searches have been optimized to detect extremely narrow radio spikes. The new study suggests future searches should also remain sensitive to broader signals that may carry exactly the same information, altered only by the environments through which they travel. In other words, scientists may not need bigger telescopes. They may need a different way of listening. Across the Milky Way are hundreds of billions of stars, and potentially trillions of planets. Somewhere among them, civilizations may have risen, built technology, and attempted to communicate across the darkness between worlds. Their messages may have traveled for hundreds, thousands, or even millions of years before finally reaching our solar system. If this new research is correct, those signals may already be passing silently through Earth's radio telescopes, hidden not by distance, but by the turbulent plasma surrounding the stars that created them. The universe may not be quiet after all. We may simply be listening for the wrong